Hi everyone, welcome back to my channel. And today we are going to solve a problem, symmetric tree from LeetCode. So, in this problem, we are asked to determine that a binary tree is symmetric around its center or not. So let's first understand the problem first. So here we are given a root. Here we are given a root of a binary tree in order to check whether it's a mirror of itself or not. So here in this image, as we can see, here the roots left subtree and the right subtree is a mirror image of each other. So it is a symmetric tree. So how can we solve this? So we will use a recursive approach here. We will first create a function. Okay, we will first create a function bull is same. Here we will write all our cases. We will take two pointers, pointer 1 and pointer 2 for checking for left subtree and right subtree. Tree node ptr 2. Then here as we can see in this image there will be three edge cases. One will be what if both nodes are null. We will return true. If both the nodes of the right subtree and left subtree are null, then it is true. So here we'll write the condition if not ptr1 and not pointer 2, then we will return true. Correct? The next edge case will be what if only one is null and other is not? So then it will be false. Then it will not be a mirror image of each other. So if not ptr1 or not ptr2, then we will return false. Why? If there will be only one pointer, like if the left subtree has only one child and if right has not, then it will not be a mirror images of each other. So we'll return false. Otherwise, we will check the value of the, otherwise we will check the left child of the first node should match the right child of the second node. And the right child of the first node should match the left child of the second node. So here what we'll check is PTR one's value should be equal to PTR two's value. And the edge cases will be, and we will recursively check each nodes. We will first check pointer one's left subtree and pointer two's right. Similarly, again recursively pointer one's right subtree and pointer two's left. Okay, done. And here in our main method, what we'll do, we'll first write a condition. What if there is no root? So if not root, we will return true. Otherwise, we will call the recursive function is stem roots left and roots right. So now we'll run and check if it's true or not. Okay. So here the function is will check whether the two substrings are mirror images of each other or not. And in the main function, if that is symmetric, here is symmetric, we just call it on the left and the right children of the root. So let's dry run once, okay? So for the symmetric tree example, as here we can see example 1. So for the symmetric example tree, it will compare first lefts 2 and then right's 2. The value matches, go ahead. Then we will now compare left's left and right's right. That is, left's left is 3 and right's right is also 3. Then next. Then we will compare left's right and right's left. That is 4 and 4. It's right. So all recursive calls return true. So the tree is symmetric now. And for non-symmetric example, as here we can see in example 2, we will compare, okay, so root is 1. Now here, left tree and right tree, two matches. Now left's left is not there and right's right is 3. So one value is 1 and 1 is not. So it is false. It is not a symmetric tree now. So, what is here the time complexity? So, the time complexity here is order of n. Since we visit every node once, right? And the space complexity will be order of h. That is, where h is the height of the tree because of the recursive set. Okay? Yes. So, this is how we will solve the symmetric tree problem from LeetCode using recursion. So, if you find this explanation useful, please like, share, and subscribe. And if you have any doubts, please comment. And yeah, wait for the next